This is section 1.2a, graphs of equations. First, let's look at some common graphs, and some of this is going to be a review of Algebra 1 and Algebra 2, and some of it might be new. What kind of equation is y equals 7 minus 3x? Sketch it. Alright, so at this point you should recognize what kind of equation that is just because you've seen it so many times. In fact, we did a lot of these in Chapter 7, as you might recall. So it's okay if you don't remember, but this is kind of a test to see how much you remember, and to also, emphasize what is going to be important for this chapter. So pause the video, try and sketch that. Just a rough sketch is fine, and then resume when you have an answer. So you should have identified that it was a linear equation, y equals mx plus b. And so the sketch, of course, is a line, which I'm not even going to bother to show you on the screen because it's pretty simple. Okay, so this is a line. It's in slope-intercept form. M is the slope, b is the y-intercept. So in this case, the y-intercept would be 7, and the slope is -3. What kind of equation is y equals x squared minus 2? Sketch it. All right, now this is getting a little harder, but I know that in Algebra 2 you did cover these kinds of curves, so you should probably be able to recognize what it is just by looking at it. Again, don't worry if you don't. This is just kind of a preliminary stuff. So pause the video, try to do that, and then resume when you have an answer or if you get stuck. This is a quadratic equation. This is a quadratic equation. And its curve is a parabola. And the polynomial form for this quadratic equation is y equals ax squared plus bx plus c. Okay, you might remember in Chapter 7 we'd sometimes use systems of equations to find a, b, and c. You also will remember from Chapter 10 that we did parabolas, but we had the standard form rather than the polynomial form. But in any case, this is a quadratic equation, and its sketch is a parabola. What you can do, since we are going to learn how to sketch these by hand in this section, for now you can just verify by using your calculator to see what x squared minus 2 looks like. And it is a parabola that opens upward, and it's been shifted down 2 units. What kind of equation is y equals x cubed minus 4x? Sketch it. Alright, now you probably did not learn how to sketch these types of equations by hand. So if you can't sketch it by hand, that's okay. Just do it on your calculator so you can see what the shape looks like. And later on in this section, we're going to learn how to sketch it by hand. So pause the video, do the best you can, and then resume. Alright, so this is a cubic equation. A cubic equation in its polynomial form is y equals ax cubed plus bx squared plus cx plus d. That's the general way that we write cubic equations. In this particular case, as you can see, we have our x cubed term, and so the a, or the coefficient of x cubed, is 1. I have my x term, and the coefficient of that, or my c, is -4, so c is -4. There is no x squared term, and there is no constant term. That's why I don't have bx squared plus d showing up. But this is still a cubic equation, And if you did this on your calculator, you should see that it's a graph that goes up and then down and then up again. Alright, so why did we do all this? This is just to give you a preview of the kind of polynomials we'll be looking at in this chapter and the next. This is very important for calculus because in calculus you're going to be working out the derivatives and the integrals of polynomials like that, like these ones, and so it's good to really master polynomials and functions before you go on to calculus. That's why we're doing this. X and y intercepts. All right, these are terms that you also should remember from Algebra 1 and 2, but since they are so fundamental, the review we're doing now is going to help you. The points at which the graph intersects the x or y-axis are called intercepts. Okay, that much you already know for sure. If x0 satisfies an equation, then the point x0 is called an x-intercept of the graph of the equation. And that makes sense, right? Because notice that with x0, and this is no matter what x is, we know that the y-coordinate is 0 because it's crossing the x-axis. And whenever something crosses the x-axis, its y-coordinate is 0. We'll go on to specific examples in just a bit. For now, this is just the way that we should remember, in general terms, what an x-intercept is. If 0y satisfies an equation, then the point 0y is called a y-intercept of the graph of the equation. All right, and that also is common sense, right? If something crosses the y-axis, at the moment when it crosses the y-axis, its x-coordinate is 0. Right, and any point that is on the y-axis has an x-coordinate of 0. All right, so that's where that's the general way of expressing a y-intercept. And this is just to reinforce what you already know about intercepts. Here on the far left we have a curve that has no x-intercepts and one y-intercept. And so you can see that it crosses the y-axis in one point. And of course at this point on the y-axis, this point that I'm pointing at right now, this point that I'm pointing at right now with my cursor, and now I'm circling it with the mouse arrow. All right, well that point obviously has an x-coordinate of 0. It has an x-coordinate of 0. Its y-coordinate is positive, and we don't need to know what it is right now, but this is just so we reinforce what you already know about what a y-intercept is. This next graph here, this actually would be the graph of a cubic equation. It has 3 x-intercepts and one y-intercept. So let's look at the x-intercepts first. The x-intercepts all have y-coordinates of 0, because any point on the x-axis is 0. Where they differ, however, in their x-coordinates. Okay, so these are 3 x-intercepts. And also notice that this graph has one y-intercept. It crosses the y-axis in one place. And that one place where it crosses it is at the origin. And so in this particular case, that y-intercept coincides with an x-intercept. But that, of course, is not always true. Notice, though, that for the y-intercept, the x-coordinate is 0 and the y-coordinate is also 0. But what's really important for a y-intercept is the fact that its x-coordinate is 0. What's important for an x-intercept is the fact that its y-coordinate is 0. Moving on to the next graph. This is a graph that has one x-intercept and two y-intercepts. So we see our one x-intercept here, it's a point on the x-axis, and we see two y-intercepts, and these are points on the y-axis. And finally, on the far right, we have a graph that has no intercepts at all. All right, so that was all just a quick review, and now we're going to get into some techniques to graph polynomials by hand. First, what you have to do if you're going to graph some by hand is you have to find the x and y intercepts. All right, and the way to do that algebraically is to find the x-intercepts of the graph of an equation, you substitute 0 for y in the equation and solve for x, because we know that for any x-intercept, the y-coordinate is always 0. To find the y-intercepts of the graph of an equation algebraically, you substitute 0 for x in the equation and solve for y, and that's because we know that for any y-intercept, the x-coordinate is 0. All right, so make sure you write that down. Again, this is just, we're still just speaking in general terms, and now on the next screen we're going to get into specifics. Example, find the x and y intercepts of the graph of y equals x squared plus 4x minus 5. All right, so as a little challenge, try to do this on your own. Remember that when you're finding x-intercepts, what's important to remember is that the y-coordinate is 0. And when you're finding y-intercepts, what's important to remember is that the x-coordinate is 0. Okay, so pause the video, try to do this on your own, and then resume when you get an answer or if you get stuck. All right, so we find the x-intercepts by letting y equal 0. Then we solve for x. So 0 equals x squared plus 4x minus 5. I just put 0 in for y there. 0 equals x minus 1 times x plus 5. I factored. X minus 1 equals 0, x plus 5 equals 0. We set each factor equal to 0. You guys remember this from Algebra 1. And so x equals 1, x equals negative 5. These are my x coordinates then for my two x-intercepts. The x-intercepts are 1, 0 and negative 5, 0. 1, 0 and negative 5, 0. Those are my x-intercepts. And by the way, another term for x-intercepts that you'll often hear is zeros. They are called zeros. All right, a 0 is the same as an x-intercept. To find the y-intercept, let x equal 0 and solve for y. And that's actually quite a bit easier because we just put 0 in for x and all we're left with is negative 5. Therefore, the y-intercept is 0, negative 5. All right, now this is an example of why you need to find x and y intercepts to plot or to sketch rough graphs of curves, because obviously you can put this in your calculator, but 2 points about that. One, we've already found from our own personal experience that sometimes calculators are problematic. Sometimes they're glitchy and you have to reboot them. Sometimes because you didn't set the window values right, it looks funny, or it's easy to misinterpret. So it's good to use your calculator, but don't become dependent on it, because sometimes they simply don't work. Second point about learning how to sketch by hand is that only if you learn how to sketch by hand do you really understand the math behind the curve. And that's why we're doing this. We're preparing you for calculus, and in calculus you're going to need to know the math behind it. So that's why we are sketching graphs by hand. Okay, and actually a third reason that I didn't mention in the beginning, but is kind of a practical point, is that there are certain parts of the AP calculus exam where you're not going to be allowed to use your calculator. Okay, so for various reasons, we're learning how to do this by hand. And so I don't want to use your calculator for this example. However, I'm going to give you the strategy right now, and then I'll let you do this on your own. So here's the strategy. 4 simple steps. The first is find the x-intercepts, and you find those by setting y equal to 0. The second step is to find the y-intercepts. You set x equal to 0. The third step is to plot the intercepts and plot points before, in between, and after the intercepts. Okay, so what do I mean by before, in between, and after? Okay, I'm going to quickly go back to the last screen to explain what I mean by that. Okay, do you see how here the x-intercepts are 1, 0 and negative 5, 0, and the y-intercept is 0, negative 5? Well, what I mean by before the intercepts is, pick a random x-coordinate that's anywhere before negative 5, to the left of negative 5. And then since our next point going along the x-axis would be 0, negative 5, you pick something between negative 5 and 0. And then since my next point going along the x-axis is 1, 0, I would pick something between 0 and 1. And then finally, since 1, 0 is my last point, I would pick an x-coordinate, a random x-coordinate like 2, and just plot that point. Okay, so that's what I mean by before, between, and after the intercepts. Okay, so this is where we were. Plot the intercepts and plot points before, and between, and after the intercepts. And finally, step 4, connect the dots with a smooth curve. Connect the dots with a smooth curve. All right, so this is the strategy. You want to follow these 4 steps in order, and you'll see that you will be able to sketch this somewhat complicated looking cubic equation. You'll be able to sketch it by hand, just following these 4 steps. So pause the video, try to do it on your own. Don't worry if you get stuck, that's okay, this is the first time you're doing this. But do try to do it on your own, and then resume when you have an answer. All right, let's go through the the solution then. Our first step is to find the x-intercept, so we set y equal to 0. So 0 equals x cubed minus x squared minus 6x. Factor out the x times x squared minus x minus 6. And factor further, x times x plus 2 times x minus 3. And we can see from this factored equation that my values that'll make this equation true are 0, negative 2, and 3. 0, negative 2, and 3. Therefore, x-intercepts are 0, 0, negative 2, 0, 3, 0. 0, 0, negative 2, 0, 3, 0. Those are my x-intercepts. Find the y-intercepts, and you just set x equal to 0. So that's pretty easy, right? Y equals 0 cubed minus 0 squared minus 6 times 0, and that obviously is 0. Therefore, my y-intercept is 0, 0. Next step, plot intercepts and plot points before, in between, and after the intercepts. So let's plot. I've got my axes there, and these 3 points just simply correspond to my x-intercepts and the y-intercept. And I didn't label them because I didn't want it to get too cluttered, but let's just go through them one by one to be extra clear. Okay, the point that I'm circling now with the mouse arrow is the point negative 2, 0. That's an x-intercept. The point that I'm circling now with the mouse arrow is the point 0, 0, which is an x-intercept, and it's also the y-intercept. And the point that I'm circling now with the mouse arrow is the point 3, 0, and that's another x-intercept. Okay, so now we plot points before, in between, and after the intercepts. Okay, so before is somewhere in this range that I'm highlighting now with the mouse arrow, anything to the left of the point that's furthest to the left. And so I'll just pick negative 3 because that's an easy value to pick. And so when I plug in negative 3, I end up with a y-coordinate of negative 18. And obviously, you know, negative 3 and negative 18 would be much lower than I've graphed it here. The only reason I graphed it up high is just to make it fit on the screen. But negative 3 and negative 18 would be 1 point. My next point, well, something between intercepts. Between these two intercepts, the two that I'm going back and forth now with the mouse arrow, between those two, a convenient x-coordinate to choose would be negative 1. So I can plot the point negative 1, 4. And then now, moving on, between these two intercepts, the next two intercepts, right, between those two, a convenient point to plot is 2. You could have chosen 1 or 1.5. Any x-coordinate that's between these two intercepts is fine. So I chose 2. 2's down here, that 2, negative 8. And again, that point would be lower, but I just needed to fit it on the screen. So you get the point. So 2, negative 8. And then finally, let's pick a point that's after the intercepts. And that would be 424. 424, which obviously would be much higher, but I'm fitting it on the screen. So I've got intercepts plotted. I've also got points before, in between, and after the intercepts plotted. And I'm ready for the fun step, which is connect the dots with a smooth curve. And you guys have all played connect the dots before. And so you get to play it now. Connect the dots with a smooth curve. Now, this is a little challenging to do with a mouse on a screen, so this is the best that I could do, which looks pretty rough, but you know, you get the idea. You connect the dots the best that you can, and with a pencil and paper you'll be able to do better than I did here, you know, with a little mouse drawing on a screen. But you get the idea. All right, you just need to connect the dots with a smooth curve, and there you have your rough graph. The classwork, page 22. Copy those numbers down, and the directions are you need to sketch all without a calculator. Okay, so whatever the directions in the book say, I want you to just follow these. Sketch all without a calculator. Sketch every single equation that's given to you in this classwork set. Sketch each problem without a calculator. And we'll see you in class.